Hi, continue the previous one after we explain about the mechanism of action of the five class or the five types of diuretics. We will see further about each types of diuretics. So again, let's start from the carbonic anhydrase inhibitors first. So after we study about the mechanism of actions, now we further see about other details of carbonic anhydrase inhibitors. So let's see. So this type of diuretics is a weakest is the weakest diuretics. So the side effects of it includes the hyperkalemia and so the wasting of H2 CO3, which is a bicarbonate, and causing the metabolic acidosis, the build-up of acid, which is build-up of acid in the body due to kidney disease or kidney failure. So example is acetazolamides, which have the weak diuretics effect. So the next one is osmotic diuretics. Just now we said that it increases solute concentration within tubules and cause water retentions and prevent water reabsorption, will reduce the plasma volume and also decrease the blood pressure. So another effect is the osmotic diuretics will filter freely at the glomerulus. So all the osmotic diuretics that will enter the nephrons and then enters into the heart proximal convoluted tubules and further into the loop of Henle to the distal convoluted tubules and further into the collecting ducts. So it will increase the osmolarity of renal tubules. It will also limit reabsorption of water in the tubules as well as it increase excretion of the ions and also water. So the use of osmotic diuretics includes the use in reductions of ICP. ICP is the intracranial pressure, and also to promote urinary excretions of toxic substances because it is diuretic, right? So it can have these functions. And further is to promote urine excretions also because of the diuretics effects because remove of water. And also we can see here the osmotic diuretics not so effective in treating edema caused by sodium retention, and it has side effects of significant fluid change, which can cause dehydration, volume overload, and also electrolyte imbalance. The example of osmotic diuretics includes the mannitol, urea, glycerin, and isosorbide. So normally glycerin and isosorbide is given orally, while if given in intravenous, such as mannitols or urea, we can expect a quick response because IV, right? So the mannitols is used in surgery and operations when it is high ICP. You will use the mannitols to decrease the ICP. So let's continue to the next one, our loop diuretics. So just now we have said about the mechanism of action. All of this will cause the ultimately effect is reduce the plasma volume, decrease the blood pressure, and the decrease of the sodium ions and increase all of these excretions and also increase renal resistance due to plasma volume depletion. So what is the causes or what is the effect of all these action is hypokalemia, because we have excretion of potassium, and then also acute hypovolemia will cause the hypotension, shock, and cardiac arrhythmias. And also loop diuretics are different from other, it will cause damage of hearing, which is also called as ototoxicity. And some examples of loop diuretics include furosemide, torsemide, bumetanide, and also ethacrynic acid. Okay, let's move on to the next one. We have thiazide diuretics. The mechanism of action is it will increase the sodium chloride excretion. In long term, we have both of these effects, which is not secrete the calcium and also promote secretions of magnesium ions from blood lumens. So it also increases excretion of the ions, 3 ions, and also water. So it will cause effects. Here we can see. First is vasodilation, because reduce peripheral vascular resistance. And the next one is hypokalemia, because the release or the excretion of potassium ion here. So next is the hypercalcemia, increase the calcium level in our plasma, because it inhibits secretions from the blood in long terms. And the hyperuricemia. Hyperuricemia is because of the increased urea reabsorption in proximal convoluted tubule, and further increase the plasma uric acid, and ultimately cause gout, and also or that will exacerbate it. And then other effects is worsen the glucose control, which is causing the hyperglycemia, and also hyperlipidemia, which is caused by the increase of cholesterol. And some examples of thiazide diuretics is chlorothiazides, hydrochlorothiazides, chlorothalidons, metolazones, and indapamides. And moving to the last one, we have potassium-sparing diuretics. Just now we said about the mechanism of actions. So what's special is it will increase. It has two categories. One is here, decrease sodium reabsorption, and also prevent potassium excretion. So which means the level of potassium in our plasma will increase. So it's called potassium-sparing diuretics. And the second type of potassium-sparing diuretics is aldosterone inhibitors, where its action is to inhibit the actions of aldosterones. So it causes potassium retentions and also increase excretion of sodium ion, chloride ion, as well as water. It will cause decreased blood pressure. So the examples of potassium-sparing diuretics includes this one and this one in the green box. So we have two categories, right? So the spironolactone and eplerenone is under aldosterone inhibitors, while the amiloride and triamterene is under the second category, which are the both effect decrease sodium reabsorption as well as prevent potassium excretion. That's all for me. Hope you enjoyed this video. Thank you.